Lesson 8.5 has us looking at some special patterns that happen in factoring. Once we recognize a special pattern, then the factoring becomes a little bit easier and quicker. So it's a good thing to know about. Go ahead and put your date and let's get going. So one of the special patterns, well, actually both of them have to do with our perfect square numbers. Do we know what our perfect square numbers are? Well, perfect square is if you take a number and square it. So 1 squared is 1, and then you can just go and square every single number. 2 squared, 3 squared, 4 squared, 5 squared, so you get 1, 4, 9, 16, 25, and you can keep going in your head. 36, 49, 64, 81, 100, and that goes on and on and on. So these are our perfect square numbers. Because we squared a number to get those, that's why they're called a perfect square number. They also have to be numbers that you can easily take a square root of, which is helpful. So those are your perfect square numbers. So how do our perfect square numbers tie in with what we've been doing? So this says factor the trinomial. Actually, it only has 2 terms, so it's not trinomial. However, you could look at this as x squared plus 0x minus 25. Now it's a trinomial. If you notice, we were missing that x term. That just meant that it was multiplied with a 0 and it canceled away. So here's kind of the long way to think about the problem. Here's a trinomial with an x squared. It doesn't have a number in front, so you do not have to guess and check. And all you do is you look at factors of c, the last number, that add up to b, the first number, or the middle one. So factors of negative 25, well, you could have 1 and 25 or 5 and 5. But because it's a negative 25, one of them will have to be negative. So I'll go ahead and make one of those negative. So if you look at the negative 1 and 25, is that ever going to add up to a 0? Even if we made the 25 negative and the 1 positive? No, that's not going to work out. But what does help us is this next factor pair. You've got 5s, 1 positive, 1 negative. Well, what do you get if you add these together? If you add the same number, 1 positive, 1 negative, you're going to get 0. So that means that the 5 and the negative 5 is our answer. So we can go and say that's x minus 5, x plus 5. That's what we were doing earlier in the chapter. So how can you recognize that and get the x minus 5, x plus 5, or you could say x plus 5 first and x minus 5 second. How can you get there just from this beginning x squared minus 25? So this pattern is called a difference of squares. You are subtracting 2 things that have been squared. So that x squared minus 25, what did you square to get x squared? Well, that's an x that got squared, minus what do we square to get 25? 5. So it's going to factor, so there's your a squared minus your b squared, and it's going to factor into that pattern a plus b, a minus b. So x plus 5, x minus 5. We just have to figure out what is it that we actually squared to get both of those terms. So this factoring is not necessarily difficult. It's pretty quick. We just have to make sure we recognize it. It's a special pattern that we'd like to recognize. So x squared minus 49, is this a difference of squares? So I see that it's subtraction, so that makes it a difference, which helps. Now, did we square anything to get both terms? So can we rewrite it like this? We have an x that we squared minus, did we square anything to get 49? Oh, we did. We squared a 7. So this fits the pattern. Our final answer, you're going to have an x plus a 7 and an x minus a 7. And that one's done. X squared minus 36, I see the subtraction, that makes it a difference. Is it a difference of 2 things that have been squared? So x squared, we got that one, minus, now are we squaring anything to get a 36? And 36 is a perfect square number, and we squared a 6 to get that. So x plus 6, x minus 6. That one works out also. All right, so these last two look a little bit different, but they're not going to be too bad. If you notice, you have a number in front of your x squared, But still, we're trying to figure out if this fits a difference of squares pattern. Do you square anything to get a 4x squared? And because 4 is a perfect square number, we do a 2x. 2x times 2x is equal to 4x squared. And then what do we square to get 25? 5. So our final answer, instead of x plus 5x minus 5, it's going to be 2x plus 5 and 2x minus 5. So your goal is basically to figure out what is it that got squared, because the 2x and the 5, that's what shows up in our answer. All right, so last one over here, are we squaring anything to get, well, not cubing something, or what, that's not cubing, it's not gonna let me erase it, I bet. Let's see, nope. So that's really a squared. There we go. All right, what do you square to get 16x squared? Because 16 is a perfect square number, we can say, well, 4 times 4 gives us 16. So that's going to be a 4x times 4x gives you 16x squared. What do you square to get a 9? A 3. And then you can go right to your pattern, 4x plus 3 and 4x minus 3. So we love these difference of squares. We just want to make sure that we remember how they work throughout the whole chapter and especially on the test. Okay, last slide. This is another factoring pattern that will come up. If you notice, these are just trinomials, x squared minus 16x plus 64. So it's not going to be your difference of squares pattern because that's just 2 terms. So now that you have 3 terms, how do we factor this? Well, the first one we can approach like we normally would. We'd say, all right, it's just an x squared, so factors of 64 that add up to a negative 16. So factors of 64 are 1 and 64, 2 and 32, 4 and 16, 5, 6, 7, 8, and 8. And we're looking for these to add up to a negative 16. Well, because it's a positive 64, that means all of your factors are positive or all of your factors are negative. And because it adds up to a negative 16, that means we have negative factors. So I'm just going to look at all these as negative values. So which ones add up to negative 16? The negative 8s. So we're going to say x minus 8 and x minus 8. So the pattern here, or what we're noticing, is that we have the same thing multiplied twice. You have an x minus 8 times an x minus 8. So we can take that one step further and just say, well, that's the same thing as x minus 8 squared. So you're going to do some factoring where you do get the same answer. This is actually called a perfect square trinomial. If you get the same answer, just go ahead and write it once with the squared on the outside. All right, last one. 4x squared plus 20x plus 25. Now, because of the 4 in front of the x squared, this is a guess and check. So we go right to our parentheses, and we say, okay, what's going to multiply to 4x squared? That's what goes in the first spot. And the second spot is what multiplies to 25. So when you do your guessing and checking, the first guesses that you can do, or the first thing you can look to see is, do you have perfect squares on the outsides? Is the 4 a perfect square number? Is the 25 a perfect square number? If they are, that's a 2x times a 2x, and this is a 5 times a 5. So those are perfect square terms. Let's have that be our first guess. It might not work, but at least it gives us a starting point. So we have 2x and 2x, and then 5 and 5. And I notice that this is all addition in here, so that means that we're going to have plus and plus. So let's just check the outside terms. 2x times 5 is 10x, 5 times 2x is 10x, and 10x plus 10x is 20x. So we got our answer, 2x plus 5 times 2x plus 5. But again, you might notice that we're multiplying the same thing twice. So we can take it one step further and say our final answer is a 2x plus 5 squared.